I welcome the online audience of the Global Energy Association. We continue to discuss the new report 10 breakthrough ideas for the next 10 years with the authors. And our guest today is Andrew Smallbone, Associate Professor in Durham University and the Director of Net Zero Research Network for Decarbonization of Heating and Cooling. Hello, sir. Nice to see you.
Hello, nice to see you.
Carbon capture and storage we are going to discuss today has a large role in potential strategies to limit the global warming and to mitigate the effects of the climate change. But is it possible to achieve decarbonization and the implementation of Paris Agreement without the CCS program?
Well, that's an interesting question. I guess the short answer to this is quite simple. If society wants to implement the Paris Agreement, then it needs to roll out carbon capture and storage very quickly. Analysis shows that future energy systems which don't include CCS are far more expensive and much less resilient. The Paris Agreement sets an agenda which points towards deep and, well, very, very deep cuts in carbon dioxide emissions. The agenda tears up any plans for using cheap fossil fuels and emitting the carbon dioxide. So it's now time to think beyond this paradigm. The future is that we're all hooked on the value of fossil fuels, hooked on the low cost, its availability, its scale, its ability to store energy and its flexibility. Our industrial and national infrastructure is shaped to use it. So this means jobs, it means businesses, it means interconnected supply chains, trade, and everything else which provides security and confidence to our communities. In practice, we need to retain all of this, but without the carbon dioxide emissions. So carbon capture and storage allows us to decarbonize quickly. It allows us to retrofit our existing power, industrial, manufacturing infrastructure without rebuilding it again. It will help us to build the renewable energy technologies we will need to deliver on our net zero targets. It will enable us to do all of this, but without the carbon dioxide emissions bill that would come otherwise.
If carbon capture is so powerful, why isn't it everywhere?
Well, it's a good question. I mean, basically, it's major infrastructure. So it takes a long time and has a large capital cost to install. The technology itself is quite mature. The principles have been demonstrated now across the world at scale, and we've all seen from these activities that it's quite viable. The next stage really is a major capital investment required in the infrastructure, in the pipelines, in storage sites, and on the plant itself. This comes with the additional energy cost and also a commitment to ongoing maintenance, which will continue over the decades. The challenge will always be that capturing carbon dioxide will always cost more than venting to atmosphere. A difficult decision now needs to be made: pay for this now, pay for this infrastructure now, or postpone it all until the next national budget or investment round. But I think the choice to delay has now reached its end. What's changed really since the net zero announcements is there's no longer any space for special treatment of particular sectors or businesses. The business as usual is over. However, in infrastructural development terms, a 2050 timescale is effectively tomorrow. So what most have now woken up to the idea that it might be technically difficult or expensive to be compatible with this future, but carbon capture is your most viable pathway. As a result, interest and investments is now starting to move towards deployment rather than demonstration.
Yes, I agree that further prospects of this technology are associated with a reduction in its cost, which is now quite, let's say, not cheap. But what is expected to be improved here in the technology? Because how it is effective at the moment, at the present time?
Yeah, so currently, if you go and look at a carbon capture system that's in demonstration, maybe a system that's looking to scale up, they're pretty effective. They're nominally capturing 85 to 90% of the carbon dioxide. And this will certainly be good enough to get the infrastructure in place and get the technology scaled up. And obviously this scale up will bring down the cost as we learn more about deploying these systems. But it will also encourage investment into what kind of termed really a second generation capture technologies or new build industrial plants or processes. And in these cases, it means going beyond retrofit plants, but to integrate carbon capture or even carbon utilization into the common industrial processes and their supply chains.
After the carbon is captured, it is buried under the ground. What are the main prospective storage sites? So what makes a good site or what makes it a bad site?
Yeah, so I mean, holistically, we need to decarbonize society as a whole. So carbon capture is not necessarily something we would aim to install everywhere. And it wouldn't go to every, we wouldn't replace every current fossil fuel technology across the world with a version of that with carbon capture on the end. There are cheaper solutions out there for many, many sectors. However, carbon capture fitted into natural gas to hydrogen plants. So using that hydrogen as a fuel or a feedstock or for high grade heat, or integrating carbon capture for heavy industries like steel or cement or the chemical sectors. It does in these contexts represent a cheap and least invasive solution. The good thing about many of these sites is that they're embedded into industrial process clusters and have developed close to ports and abundant gas supplies. So in the case of the UK, our major industrial emission sites are actually carefully and fortunately co-located next to convenient areas which have got geological CO2 storage capacity. So these kinds of sites are excellent places to start because everyone's already there. So with further development of pipeline infrastructure, this means there could be a potential for maintaining the existing industrial base, all the skills and all of the employment that are already there, while storing the CO2 into the long term.
Thank you. You mentioned cheaper solutions for the fossil industry, like what?
So I guess, yeah, we're moving first really from the demonstration phase into the deployment stage. So this brings huge benefits on cost as we move along the experience curves. We've seen this right across renewable energy technology sectors. As we scale everything up and we learn more about it, the cost comes down. The secondary benefit is that we'll start to see a new generation of carbon capture compatible industrial and power plants, which also serve to reduce cost whilst complementing the wider energy systems. I think the key thing to think about really here is that to date, almost all the environmental interventions that have come forward and have reached scales like PV, switching to wind, or changing LED to LED light bulbs have also come with other benefits over and above the carbon dioxide question. So these obviously can be cost, they can be improved technical performance, but they could also yield local air quality improvements. What's a bit different and fundamentally about carbon capture is that it's delivering exactly the same product, but without the vast majority of the carbon dioxide. It's a cost not to emit the CO2, so a cost we must pay now for future generations. And someone has to be willing for this, to pay for this. Carbon taxes is obviously one model, and there are various kind of economic models that kind of are similar to that, but also product selection from ethically minded consumers may also be another which may drive this transition. Nevertheless, there's a real growing realization that net zero targets are bringing forward lots of solutions. However, those solutions which include large-scale carbon capture are cheaper and quicker to implement.
Can we use this trapped gas, or how can we use it?
So one example that I talk about in the article is an opportunity to take CO2 and turn that into other commodity products. The one example I give in the paper is to turn it into a version of a plastic. So we were looking at replacing PET plastic with a PEF plastic. And that process, as part of the process, it actually takes CO2 and absorbs CO2 into the plastic as it's manufactured. That gives us a great opportunity to then utilize what is normally a waste product and turn it into something of higher value.
Okay, we won't open all the secrets to our subscribers, because we will present the report soon, and we will need to hide something in secret. And thank you very much for this short interview. See you next time.
Thank you very much. Thank you.